Hello? Hello everyone. Today we will continue to look at a topic in HCI storage. Today we will continue to explain a few remaining modules. So next, first is the fan module and our BBU, which is our backup power supply, the backup battery. The fan module provides cooling for the system, allowing our control enclosure to operate normally under maximum power consumption. Here, whether it's our fan or our backup battery, we can see. Here, these two are next to each other. These two are adjacent, and both of these have redundancy. It's not just a single one. Here we only drew one in the picture, but under normal circumstances we actually have. At least it's 1 plus 1. Just to ensure that no matter which one fails, we can ensure that the other modules can operate normally. If one of the fans here has an issue, the other one can temporarily support for a while. If both fans fail, then your system. Once the temperature rises after a while, it will trigger an alarm, which might lead to some hardware damage. The backup battery is the same. Although it's just a backup for our power supply, if there's a power outage, can the battery be used? Because the backup battery is generally not used. After a power outage, if the backup battery, alas, is damaged from long periods of disuse, or if there are some issues with it. If there are some issues, having multiple backup batteries is very necessary. Indeed, very necessary. The main purpose of this backup battery is to provide backup power support in case of external power supply failure, which is equivalent to ensuring the safety of the data in our storage array. Under normal circumstances, the output of our system's power supply is actually in a backup state when everything is normal. When the external power supply is completely disconnected, our backup battery starts supplying power to our system. At this time, actually, it's like this. When a malfunction occurs, it won't affect the normal operation of our system. As long as, at this time, of course, if a malfunction occurs after a power outage, then this is actually a bit of a double whammy. But generally, this doesn't happen. If it malfunctions on its own, and the overall power supply is fine, it won't lead the system to operate in this way. When the system loses power, it ensures that our system writes the cached data into the controller's built-in hard drive, which guarantees that our data is not lost. When the external power supply to the system is restored, our driver software will read the data saved in the controller's built-in hard drive and then restore it back into our cache. This is one of our features. This is a primary function of the backup battery. Generally, when using a backup power system with lithium batteries, we perform charging and discharging of the battery to refresh and check the battery's capacity. This is used to detect in advance if the battery components, when not used for a long time, will lead to a decrease in capacity. Because it is a backup power source. Backup power sources are generally not used, and if they are not used for a long time, it can lead to capacity degradation. So, it needs to be checked regularly. It must be checked regularly. These are our two modules, which are essentially to ensure the normal operation of our system, namely the backup battery and the fan. Next, let's take a look at this. Safe disk. What is a safe disk? Well, judging by its name, right? It seems to function similarly to a safe. It is actually used to store data in our storage system, including information system configurations, log systems, and cached data after system adjustments. All of these are included. As we mentioned earlier, this is used when the backup battery is activated. If the system loses power, the backup battery is used together. We will then transfer the system cache, the system cache, into our safe disk. Generally, in storage systems, there are two types of safe disks. One is the built-in safe, and the other is external, which can be connected externally. Here we have two different specifications. These are two different specifications of the safe disk. Their overall structure is actually the same. Here we have the hard drive module's alarm and location indicator lights. Below are the module's latch, the handle, and the label for the module. These are the parts, and their structure is the same. But this one is relatively thicker. This one is relatively thinner. Over here, actually. Generally, what do people see? They see these relatively larger ones. These disks are usually mainly extreme disks. As for solid-state drives, their overall volume, under the same size conditions, is actually smaller than mechanical drives. At least twice as thin, twice as thin is equivalent to only half the thickness of a solid-state mechanical drive, then the length and width will actually be slightly smaller as well. Slightly smaller. Solid-state drives are relatively smaller, and here is a stage of enemy, a solid-state drive. So this is the main situation with our safe drive. Under normal circumstances, each of our controllers will have one or two built-in SSD drives as backup sample drives. Why use SSD? If you rely entirely on mechanical drives, sometimes it might not be fast enough. What do I mean by not fast enough? Our backup battery support is time limited, and the larger your server, the more power it consumes for disk reading. If you only have one or two backup batteries, they might not last long, maybe just a few minutes, or perhaps a little over 10 minutes before they run out. In such a situation, if you're using mechanical drives, you might not have enough time to save the data, or you might only save half of it before the power cuts off again. In this case, it doesn't really make much sense. So here, we generally use solid-state drives, which are faster, as the backup drives. This way, when a failure occurs, we can quickly transfer the data into the backup solution, ensuring the integrity of our data. And also its security. Of course, you can also use external options. If it's external, generally, we can directly select 4 hard drives in the system and configure them as backup drives. Then, we can allocate 2 GB of space from each hard drive. To form RAID 1, and the remaining capacity of the backup drives can be used to store business data. When the backup drive fails, to ensure redundancy, the system will automatically select a functioning drive from the remaining hard drives to replace the faulty backup drive. This external option doesn't necessarily mean it has to be an external connection, it's just your. Others, the hard drives connected to your server can serve as backup drives. They can be used as backup drives and will be automatically selected. This is automatically chosen by the storage system, which is relatively more convenient. This is one of our... The backup drive module is used to retain important data in our system, as well as cache data after a power outage. And then, moving on, this module here is actually our most important module in a computer, without exception. Why? Because without power, nothing can function. So, for a computer, the power supply is actually the most important, and this is the most crucial part. Therefore, to ensure its high availability, we generally have 2 power supplies. For general servers, or some devices actually, can basically be equipped with 2 power supplies, at least 2. If it's a 4U server, it might be able to accommodate 4 power supplies, while a 2U server generally can hold 2. The advantage of having more power supplies is firstly, that I can provide higher power output. This means it can essentially run more complex and resource-intensive tasks. Of course, a single power supply can also operate normally. However, some servers have specific requirements for power modules. If the power consumption is relatively high, you might need at least 2. For smaller servers, 1 is usually sufficient, but having 2 can ensure redundancy. For servers with 4 power supplies, it's even more assured. The main role of the power module is to ensure that the control box can operate normally under maximum power consumption. Ideally, you should fill all the power module slots available. Install as many modules as there are slots, which is the best practice. Generally, our free control box will have 4 power modules, and for a 2U unit, there are 2. A 2U unit has 2. They are all the same. What do they form? They form a power plane, providing redundancy, and can supply power to our controller. In this case, relatively speaking, power failures are generally uncommon. Typically, power failures are quite rare. It's also relatively rare. However, if there is internal aging, or short circuits within the internal circuitry, after a failure occurs, since we have multiple controllers, or rather, multiple power sources. In the case of multiple power sources, we can actually ensure what? Ensure this. The entire server can continue to operate, but you need to as quickly as possible, replace it with a new one. This power supply is hot swappable, so there's no need to shut down, which is quite convenient. This is the overall structure of our control box. So today, we'll stop here. If anyone wants to learn Huawei certification technology or wants to obtain the Huawei certification question bank, please send me a private message. I can also engage in technical exchanges by leaving more comments below the video. So we'll stop here for today.